Welcome friends. Welcome to this revision through previous year questions. Okay. So in this particular session, we will see some of the important previous year question and the concepts related to that. Okay. So we will solve previous year questions from almost all the chapters. Yes. And then I will also discuss the theory behind it. Okay, so I'll first of all request all of you who are attending the session that they can increase the volume of their device. Yes, they can increase the volume of their device, or they can use headphone for more clarity. Okay, for more clarity they can either increase the volume of your device, or you can use headphone also, because I will be speaking at a lower volume. Okay, so welcome everyone. So we'll solve questions, but before solving the question I will explain the formula in that question. Yes, and also I will tell what variations they can do in the question. Okay, so let us start now. Before going to the first question, see, they can ask you questions on very important topic, that is the strain energy due to axial load. Okay, so strain energy due to axial loading. Okay, strain energy due to axial loading. Okay, so when I'm discussing strain energy due to axial loading, this is equal to half of the axial load into the deformation. Okay, so suppose we have a bar. Yes, suppose I have a bar like this. I have a bar like this and I'm applying axial load P. Okay, so this is the total strain energy. Now we also know that this deformation is what? It is PL upon AE, right? So this can be written as half, okay, P square L upon AE, or I can say P square L by 2AE. So this is the total strain energy due to axial loading. Now see, the strain energy due to axial loading I can write down like this. Now what I can do is I can divide it by area and I can multiply by area, right? Then I divide it by L and then I can multiply by L, right? Now see, this is what? This is area into length. This is volume, na? This is volume, right? And you see P by A is what? Stress, na? And delta L by L is what? Strain, na? So I can write down this as half the stress, axial stress, into strain into what? Volume. So the total strain energy, which was P square L by 2AE, this is also equal to this, right? This is also equal to this. Okay, now see here, this term is what then? You see, this is total strain energy, right? So this term is strain energy per unit volume. Yes, strain energy per unit volume, also known as resilience, right? Also known as what? Resilience. So now in the examination, if they're asking you total strain energy, that will be how you can find out. Directly you can use P square L by 2AE, or you can find out, you see, half stress into strain, that is what? The strain energy per unit volume, and then multiplied by the volume of that particular bar, and volume is what? Area into length. So like this, either I can use this formula or I can use this formula to find out what? The total strain energy. Okay, so Now we'll solve questions, and as I told, you can join the group for more questions and links. I am sending in this group. Okay. And if you want to search the group name directly, you can also search on Telegram Satyajit Sir PW. You will get the, either you can join by searching or you can join by scanning also. Okay. Now we'll solve questions now related to this strain energy. So this is a question. Okay. This is a question where we have what? Two bars and an axial load is applied here. So this load is common to both the bars, right? Now, if I want to find out the total strain energy, then what I will do? I'll find out the strain energy for the first bar, yes, and then for second bar, so I can say indirectly what? It is summation of P square L by 2AE, right? So use this formula and find out total strain energy now. Now you solve, okay? Now you solve. Find out. And you see the unit is given Newton mm. So convert everything into Newton mm. Okay, chalo solve this. This question came in GATE 2017. Okay, so solve. Now see, this P load is common to both. So here I can say P1 is equal to P2 is equal to 1. This P load is common to both the bars. Okay. See, both bars area is given, E is given, length is also given. It's a very straightforward question. You just need to know the formula and apply and convert everything into Newton mm, because the strain energy is asked in Newton mm. So all the units should be in either Newton or mm. So I can take P common for both the bars. Now, so I can take P square, and then I can also take 2 common. Then you see L1 by A1 E1 plus L2 by A2 E2. Others 35. Okay. Now I have to take care of unit. You see this P is given 1 kilonewton. Na? So I have to convert in Newton. In Newton it will be how much? In Newton it will be 1000 Newton, so 1000 square divided by 2. Then you see L1 is 400, A1 is 100, and this is 2 into power 5. So 400 by 100 area 1, then 2 into 10 to the power 5. 10 to the power 5 also I can take common, so I can take it outside. Plus length 2 is 900, area is 60, and this is 3 into the power 5. So 900 by 60, and then 3 10 to the power 5, 10 to the power 5 I have taken common. So see, this is 10 to the power 6 actually, and this 10 to the power 5, so I'll get only a 10 here, right? I only get a 10 here, and then I can cancel this, I'll get a 5 here. Then you see this is 4, so 2, then this is 300, and this is 5. So 5 plus 2 is 7, 7 into 5 is 35. All the units are in Newton and mm, so I'll get the answer in Newton mm. Very straightforward question, right? So if you just know the basic formula, you can solve this kind of questions. Now solve this question also. Here the strain energy is asked, stored in the bar, and here also the strain energy is asked in Newton mm. Here also strain energy asked in Newton mm. So please see the question, read the question, and solve the question. Here there is a mistake in the question. Okay, in the exam also they have committed the mistake. They have put kilonewton, whereas it is actually Newton. Okay, so we'll correct this. Okay, now solve this question. This is also from strain energy due to axial loading. See, either we can solve this question by the formula P square L by 2AE, or I can use half stress into strain into volume. We'll get the same answer, okay? So we can solve in this both ways, okay? Both ways will give me the same answer. Now see, this is load versus displacement. You see, it is written stored in the bar up to linear elastic. Up to linear elastic means till elastic limit, right? This point. Okay, because after that it is plastic. Now see, corresponding to this, the deformation is coming 2.5 mm, right? It is coming 2.5 mm. But you see, this load cannot be found out from here, right? We cannot find out the load from here. So I can use this formula. If I use this formula, what is given? Yield stress is given 250. So that means what? At this elastic limit, the stress will be your yield stress. So I can use half. Stress is given 250. Now strain I can find out. How? The deformation is given 2.5 here, corresponding to this yielding it is given 2.5. So strain will be what? Strain will be delta L by L, right? Strain is what? Delta L by L, right? So length is given how much? Your 2 meter, and this is 2.5 mm. So 2 meter means 2000 mm. So this is half strain into stress into strain. Then area will be what? Then I can multiply volume. Volume will be pi by 4 into diameter is given 8 square, 8, so 8 square. And then length is given 2 meter, so 2000 mm. Everything I have converted into what? Newton mm, right? So now I can find out the strain energy using this formula, right? Yes. So if you calculate this, you are getting how much? 125 into pi divided by 4 into 64, right? So you are getting a value of, one second, into 2.5, you are getting a value of 15707.96 Newton mm. Or we can find out in this way also. See, what will be the load? Load will be the stress into area, right? Stress into area. So stress is the yield stress, because corresponding to that point the stress will be yield stress. So 250 into pi by 4 d square, right? And this is Newton per mm square, this is mm square. So 250 into pi by 4 into d square. So we'll get a value of around, this is 4000 pi, suppose I express in pi. So once I get the P, I can also find out energy using this formula, right? P square L by 2AE, right? So you see, P is in Newton, na? So directly I can put here Newton. So 4000 pi square into length is 2 meters, so 2000 divided by 2. Area is pi by 4 d square, and E is given to us. E is given 250. Okay. Okay, E is not required. Okay, we cannot use this formula. We can use this formula. Half load into deformation, because E is not given. I can use half load into deformation. So half load we got is 4000 pi, and delta L we got is 2.5, right? So from here also you can solve, okay, and you'll get the same value, right? How much? Same value, 15707.96. So these are the questions from strain energy due to axial loading. Yes, and there is a very good chance that they can ask you a question from this in the examination. Okay. Now let us see some questions from columns. Okay, from columns. Yesterday, those who have attended the marathon also, means a revision, there also I told that in columns from buckling load, what they ask mostly is what? Comparison of buckling load, ratios of buckling load. So this is a similar question. Okay, so read the question and solve this question. You can find E, again that will be lengthy process. So you can find out E and then you can solve. So you can find out E, stress by strain, and then you can solve. Again, this is also correct. Multiple ways to solve the same question. Now solve this question. Here you see what is given. Buckling load of column 2 to buckling load of column 1. Yesterday also I told that, those who have attended the session, that in columns and especially buckling of, they ask buckling of columns, and mostly they ask what? Ratios. You can see it was 17 also they have asked ratio. Very straightforward question, 2 marks. If you know the formula, if you know the effective length at support conditions, yes, then you can easily solve this kind of question. For this, you should know the effective length and the general formula, right? The general formula is what? You see, pi square E I minimum by effective length square. This is the formula of buckling load. Now see, they are made up of same material, right? See, E is given, but they are made up of same material, right? Yes, and you see the cross section is also same. The cross section is also same. So if the cross section is same and same material, cross section same means E I will be same, and same material means E will be same. So when I take the ratio of their buckling load, it will be the reciprocal of the, it will be reciprocal of, or I can say it will be effective length of 2, then effective length of 1, and then whole square, right? Reciprocal of there. Sorry, 1 by 2, na? Yes. I can say this will be effective length of 1 by effective length of 2 whole square, because buckling load is inversely proportional to the effective length square, right? Yes, all other factors are same, so they will get cancelled, right? Yes. So now you see, it is asked P2 by P1, so I will take effective length of 1 by effective length of 2. Now see, column 1 end is fixed, other is free. So effective length will be how much? 2 times of L, right? Yes. Then column 2 one end is fixed, other one is pinned. So it will be how much? It will be L by root 2. So square. So L get cancelled. This root 2 goes up, 2 root 2. 2 root 2 square is your 8. You see, very simple. If you know the effective length for all the 4 cases, right, which yesterday also I told, so you can directly solve this kind of questions. Now you solve another question. You see, another similar question asked in 2018. You see, another similar question. okay, ratio of the buckling loads, okay, based on that concept. Now they have changed the cross section also and changed the height also, okay. Now solve this question. So in buckling loads they ask you these ratios a lot. Suppose this column you can take 1 and this column you can take 2, and suppose buckling load for column 1 is P, so what will be the buckling load of column 2 in terms of P? Now see, support conditions is not given, so you can assume same support conditions, okay. Sorry. Sorry, I have little cold. Okay, so most of you have solved it correctly. Okay, so you see, so what I will do, I'll do this ratio thing now. So P2 by P1, you see, for the column 2, and you can assume any support condition, it will be same. Suppose I'm assuming that both ends are pinned, so effective length will be equal to length, okay, right? Now see here, when I solve this for P2, it will be 0.3a into 0.5a, right? The I minimum, right? 3a into 0.5a cube by 12, the I minimum, right? See, E will be same material. See, nothing is mentioned means same material, right? And pi will get cancelled, right? So this is I minimum for the column 2, and then effective length will be how much? It is 1.5h, so I can take 1.5h square. Then divided by, for column 1 it will be your 2a into a cube, right? It will be 2a into a cube by 12, and then I'll divide it by this effective length square. Effective length will be h, so h square divides, so it will go up, right? So it will be h square, right? So now we can solve this very easy. 12 will get cancelled, a cube all will cancel, so this will 3 into 0.5 cube divided by 1.5 square into 2. So this will be 3 into 0.5 cube divided by 1.5 square divided by 2. So it is coming, you see, 1 by 12. It is coming 1 by 12. So I can say P2 will be P1 by 12, or I can say P by 12. That means in GATE they regularly ask questions from this ratio of buckling loads, and this you should must see before going to the examination, right? You should know the equation of buckling load, and also you should know the effective length of different support conditions. Okay, so right answer is this. So in between, let us solve some questions of your deflection also, to just keep up the mood. Okay, so please solve this question of deflection. Read the question carefully and solve the question. See, yesterday I have told the standard cases are very important. Okay. See, there are many standard cases like in simply support beam. Okay. In a simply supported beam, yes, if we have a UDL acting throughout and for a simply support beam, if we have a point load acting, okay. See, the standard cases are very important. In the examination, many questions they ask only from the standard cases. Okay. And if you remember the formula, you can solve direct questions and some indirect questions like this. You see here the central deflection is 5 WL4 by 384 EI. Here the central deflection is your P L cube by 48 EI, right? And then here the slope at supports is WL cube by 24 EI, and here the slope at supports is PL square by 16 EI. All these formulas you should have, remembered properly, okay? All the standard cases. Now see what is given in this question. It is given that the UDL is acting on half of the length, right? Okay, starting from one end. So something like this, it is acting, right? Now see, this is similar to this. These two loadings are same. This and then other half, same. So this and this are same, right? So this plus this will give me the total one, because here it is pinned at both ends only, right? So this will give me total one. So suppose this is here, suppose deflection is y, and suppose this is y, central deflection is y. So I can say what? 2y is equal to central deflection for this. So central deflection for this is what? 5WL4 by 384 EI. So what will be y for each case? It will be 5WL4 by 768 EI. Understood? So if you know the standard formulas, you can easily solve many of the deflection questions. Okay. So we'll solve another question where they have also asked the standard formula. Okay. This question you solve 2017. Solve this question. From standard formula only they ask many questions and then the application of that. So now also we'll solve also, and yesterday also we solved some question, and more questions I am giving in the group. And also today at 7 p.m. we will have more question practice. Those are not previous year question. There also we will practice questions. So solve this question now. A is the answer. Yes. You see, mid-span deflection means central deflection. Now for this the formula is what? 5W, which is 6. 5WL4 divided by 384 EI. See, we can find in terms of EI also because both of them are same EI. So 5 into 6 into 4, 4 to the power 4, sorry, WL4 na. So 4 to the power 4. 4 to the power 4 divided by 384. Okay, 5 into 6 into 4 to the power 4 divided by 384. So I'm getting, you see, 20 by EI, right? Now this is P L cube. Here length is 2 meter, right? Total length is 2 meter. Here length is 4 meter. So P L cube by 48 EI. Right? So this is 8, 6 to 20. So again 20 by EI. So we are getting the same deflection, right? Now you see this particular thing, okay? This particular thing, if you know the standard formulas, yes, if you know the standard formulas, then you can easily solve, right? You can easily solve. Okay? Okay. Let us solve some more questions on Mohr circle. Let us solve some questions on Mohr circle, okay, to change the mood. Okay, this I have discussed also many places. Okay, so please solve this question. Yesterday also, those who have attended the marathon, there also I have discussed this about Mohr circle. So please solve this question. Okay, you see, this is uniaxial, na? This is uniaxial, and you see here, this is tensile, right? So that means center will come on the positive side. So P is 3. This is pure shear. Pure shear means this one. This is also uniaxial, but this is what? Compressive. So the center will come on the negative side, right? And this is hydrostatic with compressive. So there will be a point, and that point will be on the negative side, right? So it is 3, 4, 1, 2. 3, 4, 1, 2. So right answer is A, right? So this we have discussed earlier. Okay. Next, solve this question. Yesterday also we have seen this formula of stress transformation. So please solve this question. God bless such children. 0, yes, 0. So now you see here, yes, we have know the formula for normal stress on any plane, right? At angle theta. What is the formula for normal stress? It is sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta. This is the formula for finding what? This is the formula for finding the normal stress, right? Yes. This is the formula for finding the normal stress. Yes. So now you see here, this is sigma x. Sigma x is tensile, so it is positive 100, right? Sigma y, you see, it is compressive, so it will be minus 100. Now see, this plane we have to take from vertical, so this is also 45 because this is 45 means this is also 45. and this is anti-clockwise, so I can take theta is equal to 45 degree. Now see, there is no shear stress acting on this plane. That means what? Tau xy is equal to 0, right? So we can put here, you see now, see, this will be cos 90, na? Theta is, cos 90 is 0, so this term goes. Tau xy is 0, this term also goes. So now normal stress will be simply, you see, sigma x which is 100 and sigma y which is minus 100 by 2. So normal stress becomes what? 0. So if you know the basic formula, okay, uh, uh, this is the basic formula. This is the basic formula. If you know the basic formula, you can solve. Now another interesting question we will solve. This is for the angle in degrees for finding the plane of maximum shear stress, right? So this is what? This is the angle. This is the angle theta s they are asking, right? So yesterday, who have attended the session, I have told that theta s is theta p plus 45 degree, right? Yes, theta s is what? Theta p plus 45 degree. Yes, kindly ignore, okay? Kindly ignore whatever that person is writing. So please ignore, please focus on this thing, okay? Please ignore, okay? Please ignore. So we have exam coming up in 1 month, so very serious thing. Many people's life are at stake, right? Not only us, our family members, many people will be affected. So such people will always exist, so please ignore him. So you keep writing, Mr. Lokeshwaran, please keep writing. Whatever you want to write, write. When you get tired, then you go somewhere else and write there, okay? Write whatever you want to write, okay? Now see this question. Now we know how to find out theta p. Tan to theta p is equal to, we use this formula na, 2 tau xy by sigma x minus sigma y. Now once you find out the theta p, we can find out theta s by just adding 45 degree. So please solve this question. See, this is the stress element given, okay? Use the signs properly. Use the signs properly, okay? You see, sigma x is how much? Sigma x is 80, na, because it is tensile, right? Sigma y is how much? Sigma y is, you see, it is compressive, so minus 20, na. And tau xy, if you see, tau xy, you see top and bottom. Top and bottom is creating anti-clockwise. That means it is also negative. Yes, it is also negative, right? So now we can put the formula, right? We can put the formula. So this will be equal to 2 tau xy. So 2 into minus 25. Then sigma x is 80 and is minus 20, na? So 80, then minus of minus 20. So this will be, you see, minus 50 by 100. It is minus half. So theta p will be how much? If you find out, theta p will be equal to half of tan inverse of minus half, right? Yes. So when I find out this, tan inverse of minus half and then divide it by 2, I am getting, you see, minus 13.28 degree, right? So this is the case. What will be theta s? theta P plus 45. That is equal to, I can find out, I will just add 45. I am getting 31.7. So again, if you know this basic formula, yes, as explained yesterday or in classes also I have explained, then you can easily solve this kind of questions. Let us solve another question on this Mohr circle and transformation of stress. Now this is a very interesting question which was asked 2 years before. Okay, I'll explain this question to you and how to solve this kind of questions. So if they give something like this, what is the meaning of this? Okay, what is the meaning of this? I'll explain to you, don't worry. Okay, so suppose they are giving a question like this. Okay, and they are mentioning some normal stress here and some shear stress here. So basically this diagram is this diagram only. They have just mentioned, you know, a part of the diagram. This diagram is this diagram only. Okay, yes, this diagram is this diagram only. Understood? This diagram is this diagram only. This is just, they are mentioning only one part. Okay, they are not writing the entire one. So sigma y, this is sigma y, sigma x, right? This is also sigma x, right? And this will be sigma y, yes, and this will be your shear stress, right? This is your shear stress, right? So when they are mentioning like this, they will only mention this part, right? So they will be mentioning, so whatever stress they are writing, this will be sigma y, right? And whatever stress they are writing, this will be sigma x, right? And whatever, you know, shear stress they are writing here, that will be what? Tau xy, right? Understood? So instead of giving this, they might give this. So from this you have to understand that this is sigma y, this is sigma x, this is sigma n on that plane, this is the shear stress on that plane. Now coming back to this question, you see here, in this diagram you see sigma x is given in this direction, sigma y is given. Now you see here, shear stress is given and normal stress on this plane is given, right? Right? And they're asking the value of sigma x and sigma y. Now see, there is no stress given on this. That means indirectly what? Tau xy is 0, right? So indirectly this diagram I can simplify in this way. This diagram I can simplify in this way, that there is sigma y here, yes, sigma x here, and this is the plane given, and normal stress is given how much? Normal stress is given 120, yes, and then you see shear stress is given upwards, it is given 70, it is given upwards, it is given how much? 70, yes. Now they're asking the value of sigma x and sigma y, yes. Now how to solve this kind of questions? In this, we know the equation for this normal stress. Now what is the equation? Sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta. Now here in this diagram the tau xy is not given, that means tau xy is 0, right? So this will be, this term is 0. Now shear stress, now normally see the shear stress equation gives us shear stress in this direction. Now it is given in the opposite direction, means we will take this as negative, right? We can take this shear stress as what? Negative. So this shear stress I can take negative, and the equation is how, what? The equation was sigma x minus sigma y by 2 sin 2 theta, right? Plus, not plus, minus tau xy cos 2 theta. Again tau xy is 0, so this term goes 0. Now see, sigma n I get 120 and shear stress I get minus 70, right? Yes. Now we have got two equations and two unknowns, sigma x and sigma y, and the two unknowns. Now theta is also unknown, but we can find out how. They have given the information here, you see. What information they have given? that you see PQ is 4, QR is 3, right? PQ is 4, QR is 3, and PR obviously will be 5. So they are giving this information, you see. This is 4, this is 3, right? But if you remember, for this plane, theta we takes always from what? From the vertical in anti-clockwise direction, na? So this is theta, na? This is theta. So can we find out theta? Yes, we can find out this angle, right? We can find out this angle. This angle will be how much? Tell me. This angle will be, you see, this angle will be tan inverse of 4 by 3, na? Yes, you see, it is given 4, this is given 3. So this angle will be tan inverse of 4 by 3. How much is this value we are getting? Tan inverse of 4 by 3. So tan inverse of 4 by 3, we are getting 53.13. So this angle, how much I will get? 90 minus this. So I'll get 36.87 degree. So I got my theta also, right? Because theta is always from the vertical inward for that plane where you're finding the normal stress. For the plane where you're finding the normal stress and shear stress. Yes, that is always anti-clockwise. Now see this equation. Now see this equation. We got theta, we got this. So this is two equations, two unknowns. Na? Please solve. Please solve this. Now two equations, two unknowns. Please solve this question. Chalo, you solve this question. You can take this to this side. Cos 2 theta. From this I will get this equation, and from this I will get now the two equation, two unknowns, right? Yes. Now two equation, two unknowns. Now this is solving the two equations, two unknowns. Okay, you can solve this. Okay. Okay. So from here I'll get sigma x is equal to 67.5 and sigma y I will get how much I'm getting 213.3. Okay. So one option is there. Yeah, C option is there. I will again repeat this. I'll again repeat this for such kind of question. Okay. For such kind of question, if you are giving diagram like this, you have to interpret the diagram. So if they're giving a plane like this, that means this stress is sigma n and this stress is your tau on that plane. Yes. And then this stresses will be sigma y, this will be sigma x. And then you have to use the equations of stress transformation. And then after that, for angle finding and that, you have to use some common sense also. Okay. Understood? Let us solve another question similar to this. Okay. Let us solve another question similar to this. You see this another question which they asked in 2021 also. Similar question, you see. Here also they have given planes like this, right? Okay. Now this you will solve, okay. They have given this and they have asked find the shear stress component sigma xy. Sigma xy means indirectly they are asking what? Tau xy. Okay. So they are asking you tau xy. Okay. On this plane, this tau xy they are asking you. Okay. So find tau xy. Okay. Now use your knowledge and whatever I have told in the previous question and use that and solve this question. Okay. Chalo. Similar question. This is indirectly that sigma n, right? And this is that tau. Sigma x and sigma y are given. See here the catch is you have to take the angle correctly, na? You have to take the angle correctly. You see something like this is given, right? This is given 30 degree and this is given sigma y and sigma x and then tau xy. And here some stress is given, that is the normal stress, and then shear stress is also given. Now see the theta angle will be always from vertical in anti-clockwise direction, right? So here the angle will be 60 degree. The theta will be 60 degree. And then I can use the equation sigma n will be equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2. Yes. Then cos 2 theta means cos 120 plus tau xy sin 120. And this normal stress is given how much? It is given 120, right? So this value is 120. Now I can find out this value, right? If I solve this, I can find out this value of now. Yes. So you see here, sigma n is 120. 35.640. So 75.6 divided by 2. 37.8. And then this value will be 40 minus 35.6 divided by 2 into cos 120. This I am getting as minus 1.1. Okay. Plus tau xy sin 120 is 0.866. So from here I can find out tau xy will be equal to 120 minus 37.8 plus 1.1 divided by 0.866. Approximately I am getting what is written, round to one decimal place, so 96.2 ampere. See, I use the equation of sigma n, right? Yes. See, you can also use tau equation also, na? From there also you can solve, you get the same value. Tau is given how much, you see? And it is given downward like this. So it is given how much? 50, na? So I can use this also. 50 is equal to sigma x minus sigma y, that is 40 minus 35.6 divided by 2. So 2.2 sine 120. I'll get 1.905 minus tau xy cos 120. So from here also if I find out 50 minus 1.905, yes, divided by cos 120, here also I am getting tau xy is equal to what? Same 96.2. So you can use any one of the equations, right? You can use any one of the equations. So you see, they ask you questions from stress transformation like this, and if you know the formula properly, see there are two, three things, right? One thing is you should know the formula properly. Another thing, you should know the sign convention properly, right? You should know the sign convention. And another thing also important is what? You should be able to correctly use the angle, right? If you use wrong angle, then answer will be wrong, right? So angle always take from vertical anti-clockwise. Okay. Okay, so some questions we solve. Let us solve some questions on torsion also. Okay. Let us solve some questions on torsion also. Huh. Okay, solve this question, torsion. How many years question previous? As much as possible. By this time you should have already solved all the questions of last 30 years also. Somebody asking how many questions we should solve. We should solve as many as possible. Here I am trying to solve some of the important ones you should know, and but you should solve all of them. And not only previous year questions, you should solving much more than your previous year questions. Those who have attending the batch classes, so they solve not only previous year question, they solve many questions. Okay, please solve this question. Yesterday we have discussed, and we also know that the formula for maximum shear stress due to torsion on a solid shaft is what? 16T by pi d cube, right? This is the maximum shear stress formula, right? Yesterday, who have attended the session, we have revised this formula. So they ask a lot of questions from this formula. Yes. So it is written that the maximum shear stress is tau. Okay. So tau is equal to this value. Okay. When the diameter is d and the torque is d. Now the torsion is increased by 4 times, diameter is increased by 2 times. So if we increase the torsion by 4 times, so it will become 16 into 4t and diameter by 2 times, so pi 2d cube. So this will become how much? 4 into 16t by pi d cube, and then you see this is 2 cube means 8, na? So you see this will be 1 by 2 of 16t by pi d cube. Now 16t by pi d cube is what? Tau. So this becomes what? Tau by 2. So they ask you questions from this maximum shear stress of your, for torsion they ask, so this formula is must. Okay. Now they also ask hollow cylinder also. They also ask hollow cylinder also. Now see what is given. Hollow shaft, the allowable shear stress is 125. Allowable shear stress means the maximum shear stress, right? The maximum shear stress is given to us. Now the maximum shear stress for A hollow shaft, we have discussed yesterday, it is 16T by pi d naught cube into 1 minus beta to the power 4. Where d naught is what? D naught is the external or outer diameter, and beta is the ratio of what? Inner diameter and outer diameter. Yes, this is the formula for maximum shear stress in hollow shafts. Now see, use this, and what is it? The maximum torque that the shaft can resist. Indirectly they're asking you to find out the T. Okay, so they ask you questions on the maximum shear stress both from solid shaft and hollow shaft, and you should remember this formula. This is very important from your GATE point of view for torsion chapter. And so it is given in kilonewton meter. So don't forget to convert into kilonewton meter. So see, from here I can see torsion will be equal to, the maximum shear stress is given 125. Now I'll multiply pi by, this is pi, I will multiply pi into outer diameter is 100 na. This is outer diameter 100. So 100 cube. Then you see the ratio, this is inner one. So the ratio of inner to outer is how much? It is 0.5 na. It is 0.5. So 1 minus 0.5 to the power 4, and then this divided by 16. So divide by 16. Now see, this maximum shear stress is Newton per mm square, right? And this is mm cube. So Newton per mm square, mm cube, the answer will be Newton mm. So if I want to convert into kilonewton meter, I'll divide by 10 to the power 6. So these two will get cancelled, and rest if you find out, you will be getting a value approximately how much? 23 kilonewton meter. So these formulas become very important. Okay, maximum shear stress in solid shaft. Okay, they ask you questions. They also ask you questions from hollow. Both you should remember. Okay. Okay. Now in torsion, they also ask questions from the angle of twist. Yesterday I have told angle of twist and torsional strain energy. Okay. So I'll explain here. You see, angle of twist is what? Formula we know, it is TL by GJ, right? And if I say strain energy due to torsion, it is nothing but half torsion into angle. That will be what? Half. You see, this is TL by GJ. If you multiply this, this becomes what? T square. T and T square L by 2GJ. Now see, this formula is very similar to your strain energy due to axial loading, right? We just saw at the starting of the class that strain energy due to axial loading, yes, strain energy due to axial loading was what? It was half load into axial deformation, and axial deformation was what? It was PL by AE, right? And then for the formula we are getting what? P square L by 2AE. So it's very similar to that. You can remember the formula. Now solve this question which was asked recently only. You see, they have given many things. They are given two statements. The maximum rotation means they have asked the theta, okay, and then the torsional strain energy means the strain energy due to torsion, and they have asked which statements are correct. So very straightforward formula based question. You see, very straightforward formula based question. If you know the formula correctly, you can easily solve this kind of questions. B. See, theta is very easy. It is TL by GJ. Now torsion is given 100 kilonewton meter. So 100, and length is given 5. So what will be the unit of TL? Kilonewton meter and then meter. Kilonewton meter square. Now see, GJ is given 50,000 kilonewton meter square per radian, right? So it is, you see, 50,000 kilonewton meter square per radian, right? So radian will go up. So kilonewton meter square get cancelled, and I'll get the answer directly in radian. So if you solve this, 5 get cancelled. So 100 by 1000 will get how much? 0.01 radian. So statement 1 is correct, right? Now when we see this second statement, torsional strain energy, I told it is T square L by, this two term is there, very important, right? The two term is there. So it will be equal to, torsion is how much? 100. So 100 square, length is how much? Length is 5 divided by 2. Gj is 50,000. Now see, this is kilonewton square meter, and this is kilonewton meter square, right? This is kilonewton meter square, right? Sorry. This is kilonewton meter then square, right? And this is kilonewton meter square. So this comes, you see, kilonewton square then meter cube, and this is kilonewton meter square. So kilonewton cancel, remaining is kilonewton, and this kilonewton meter. So the answer will be kilonewton meter. But when you solve this, 100 square into 5 divided by, so getting 0.5, na? So we're getting 0.5. This is not 1.5. So if somebody misses this 2, then they will get 1, na? So therefore they might commit some mistake if they don't know the formula properly. Yes. So statement 1 is correct and statement 2 is wrong. Okay. Let us solve some more questions. Okay. Let me see. I'm just juggling the questions so that we are little we keep the interest. Otherwise, if you're solving the same chapter, then we feel little bored. Okay. Let us solve some questions from shear force and bending moment also. Now shear force, bending moment, more questions I have put in the 7 p.m. session. Okay. Now solve this question. You see, they have asked, read the question and solve a lengthy question. I can't read. Read the question and solve. They have asked the shear force and bending moment at the supports. So shear force and bending moment at the supports for a cantilever beam is actually the support reaction and the support moment only, right? So indirectly they are asking you to find out the support moment and support reaction. I'll just simplify this. There are 3 beams, 3 cantilever beams. One cantilever beam, a point load is acting. Yes, all of them are 8 meter. Another cantilever beam, there is a UDL acting. Another cantilever beam, there is a moment acting. All of them are same. So they are asking the shear force and bending moment at the supports. For this, we need to know the reaction at the supports, right? If you see first one, for the P1, this is 80 kilonewton, and this length is 8 meter. So what will be the reaction force here? 80 only to balance that. And you see this moment generated will be 80 into 8, 640. So here it will be 640, yes, kilonewton meter. So if I see the shear force of P will be, this is positive, so 80 kilonewton, and you see bending moment for P, see it is anti-clockwise, so it will drop it, right? So this is minus 640 kilonewton meter, right? Then for the second one, there is UDL acting, right? 20 kilonewton per meter, right? So UDL acting, so the net load will be 20 kilonewton per meter into 8. So net load will be how much? 160. So here 160 will be acting, and then this 160 will be acting here at distance of how much? 4 meters. So moment generated will be 160 into 4, right? Will be 640 again. So here the moment generated will be 640 again. So I can say that for Q case also the moment generated is support is this only, but the shear force for Q is how much? It is 160 kilonewton. Now see for the third one, you see the moment is 640 here. Moment is 640 here. Yes. So here also the reaction moment will be 640, and then there is no force acting, so shear force will be how much? At support it will be 0 only, right? So SR is 0. So when I compare, you see here, when I compare, I can say that SQ is more than SR and SQ is also more than SP. And they have asked the magnitude. So magnitude wise, this, see, this is actually positive one, right? This is actually positive one, because it is clockwise. So here this is 640, but it is positive. But they have asked what? Magnitude, right? You see, they have asked magnitudes. Magnitude wise they are same. So option C. Okay. Now solve this question also of your this. First you solve, then I will explain this. Okay. First you solve, this is an MSQ question. Okay. First you solve, then I will give some light also for this. First to give your answer, then I will put some light for you. Okay, I'll explain now. See, whenever there is a moment, okay, suppose we have a simply support beam, okay, we have a simply support beam like this, and suppose there is a moment M acting like this. Anywhere in the beam, suppose anywhere in the beam there is a moment M acting like this, suppose, right? So what will happen if this is the length L? Then what will be the reactions in this case? Here, because this moment is acting like this, so it will try to press it. So here the reaction will be, M by L. What is happening? One second. Here the reaction will be upward and M by L, and here the reaction will be downward and M by L. Yes, because then only what will happen? This will generate a opposite moment to this, right? Yes. Now see, in this case, if I do another beam, suppose another beam is there, okay. So suppose here there is clockwise moment of M, and suppose there is anti-clockwise moment of 2M. Suppose this kind of diagram is given. Yes. So what will happen here? You see, the net moment will be how much? In this case, the net moment will be, suppose 3m, suppose 3m. The net moment will be 2m, na? Yes. Suppose 3m. So net moment is 2m and this will be in this direction, right? 2m in this direction. Yes, in this direction. Yeah, this is in same direction. Sorry. I have to take opposite direction. Sorry. This is 3m. This is in same direction. I'll take in opposite direction. If I'm taking in opposite direction, then net moment will be in 2m in this direction, right? Yeah. Yes. Net moment will be 2m in this direction. Now see, this is trying to press this and lift this. So reaction here will be upward, and how much? 2m by total length. So 2m by L, and here it will be how much? Opposite to that, 2m by L. Yes, like this, right? Yes. Now in this question, what has happened, you see, this both moments are what? These both moments are opposite to each other and they are same. So net moment is 0 here. So if net moment is 0 here, the reaction at supports will be what? 0. There is no reaction in the support. So the first option is correct, right? So first option is correct. Now see here in this question, if I draw the shear force diagram, first there is a downward load, so shear force will decrease. Then no loads, constant. Then upward load, 0. So here the shear force will be negative and value will be m by L. That means shear force is not 0 here. Why? The shear force is not 0 because there is support reaction, right? Here what happens? There is no support reaction. If I draw for this, it is simply like this, you see. There is no reaction only. There is no reaction, or I can say a reaction is 0. There is no reaction. Only there are two moments here. Only there are two moments here. Yes. Only there are two moments here. There is no reaction. So reaction is 0. If I draw the shear force diagram, it is 0 only, right? There is no load. So shear force is 0 everywhere. That is true. Bending moment is 0 everywhere. This is not true. This is not true. Why? You see, this is M, this is M. So if we go from here, suppose I want to draw the bending moment diagram. Yes. What will happen, you see here, from here to here, there is no load, there is no bending. So bending moment is 0. Here what happened, you see, there is a anti-clockwise movement, right? So what will happen, there will be a sudden drop in the bending moment. Here it is 0, 0, 0, 0, 0. Then suddenly it will drop to minus m. Then there is no load, no moment acting, so bending moment will be constant. And then here clockwise, so again it will increase to 0. So therefore in this portion there will be a constant bending moment of m, and then here 0, here 0. So that means bending moment is 0 everywhere. That is wrong here. Shear force is 0, right? Then deflection is 0 everywhere. Wrong, because if there is bending, there has to be deflection, right? If there is bending here some bending, there is bending moment is there, that means there will be deflection in this portion. So therefore I can say this is also wrong. So right answer is what here? A and B. Right answer is A and B. So remember that when I'm solving this kind of questions where there is only simply support beam and suppose simply support beam and this kind of thing is given, then you can find out reaction in this way. Suppose I ask you a question, okay? Now you tell me, okay? I'll give you a question. Okay, this the diagram is given. Suppose I'm asking you to find out. Okay, I'm asking you to find out the first. Tell me reaction at supports. Find me the reaction at supports. Find out the reaction at support. Tell me. How to find out reaction at support? Very easy. Find the net moment and let it act anywhere. Okay, net moment is how much you see? Net moment is your 40 in this direction, right? Net moment is 40. So the reaction will be simply the net moment divided by total length, which is how much? 8. So 40 divided by 8 is 5 kilonewton. So this is also 5. This is also 5. Now tell me which one will be upward, which one will be downward. Tell me which reaction will be upward, which reaction will be downward. Tell me. Value we have got 5. Which reaction will be upward and which reaction will be downward? So by common sense also you can find out, right? Common sense. You see, this moment, this net moment is trying to lift this and trying to press this, right? Yes, it is doing like this. Yes, see, this moment, net moment is trying to rotate it like this. So the reactions has to be such that it has to be opposite to that. So here the reaction will be downward. Yes, and here the reaction will be upward. Then what will happen? You see, this will generate opposite moment, right? This will generate opposite moment, right? Yes. So if they ask you reaction, we can find out the value, also direction. Now see, if I draw the shear force diagram, it is very easy, right? If I draw the shear force diagram, very easy. First you see pipe upward, and then there is no loads acting. See, bending moment won't affect the shear force. So 5 upward, here 5 upward, then no load, so shear force is constant, and then downward. So the shear force is constant everywhere, and it is how much? 5 kilonewton. So if they ask a question that what is the value of shear force, it is 5 constant everywhere, right? Yes. Now the interesting thing is the bending moment, okay? The interesting thing is the bending moment, right? Can you give me the value of bending moment? Suppose this point C and D. Can you give me the value of bending moment at B and C? C and D. Here anyhow it will be 0 at A and B. Can you give me the bending moment at C and D? How we can find out bending moment? I can take this area, na? You see, I can take this area and add to the previous bending moment. Yes. So here you see it is 5. So 5 into 2 is what? 5 into 2 is 10. So here it is 0. I will add 10 to this. And here shear force is constant. So bending moment has to be linear, right? Bending moment has to be linear. So here it will be 5 into 2, 10. 0 plus 10 is 10, right? Yes. Now see interestingly what will happen here. See interestingly what will happen here. It is 10, but there is a clockwise moment of 20, na? So clockwise moment of 20 makes a sudden jump, right? Yes. So here the bending moment will be actually 30, right? Actually you have to report what? 30. Because there will be a sudden jump as soon as C is reached. Yes, because there is a clockwise movement, right? There is a clockwise movement. Okay, there is no space here, so I have to draw little below. Okay. So I'll make it draw like this. So this is 10, and then there is sudden rise, so it becomes 30. Then again we have to add this area. This area will be how much? 5 into 3, 15, and it will be linear only, right? So it will become how much here? It will become 45, right? It will become 45. But what happened here, you see, there is an anti-clockwise moment of 60. So there has to be a sudden drop here. So we'll report how much? We'll report minus 15, right? And then you see, then again linear, and this area will be how much? 15. So it will become 0 now, minus 15 plus 15, 0. So this is the bending moment diagram, right? Yes, this is the bending moment diagram. You report after the moment, okay? Whenever they're asking you the value, report after the moment. So that means if they're asking you at C, you have to mention 30. They're asking you at D, you have to mention minus 15. Yes, you have to mention minus 15. Yes, or they might ask you diagram also. Okay, so in this kind of when there is simply support beam and there are moments acting, this is the way to find out what the reaction force, SFD and BMD. But in this question they have asked a very simple one, right? Okay, this is very simple. Why? Because both the external moments are same and they are opposite. So what happened? So therefore net moment was 0, and therefore what happened? The reaction was 0. Reaction became 0, so shear force became 0. But bending moment was not 0 in this part, and therefore there will be deflection in this part. Yes. So this is an interesting question. We solve this question. Okay. Now solve this question. Similar question I have solved in the marathon and also in the not marathon, revision session, and also for in the crash course also, you see. So it's an external moment not acting at the free end but at half distance. So for such kind of how to solve I have explained also, right? So apply that and use. Again, you see, if you know the standard formulas, you can easily solve this question. It's acting at L by 2, na? Okay, now solve this question. Very straightforward, easy question. Very straightforward, easy question, right? See, so fast you are able to solve, so fast. What you have to do? You have to apply the load till here, right? Till A distance. Now load means here moment, right? So apply the moment till A distance, right? So the deflection at the free end will be the deflection below the load, where we will take length is equal to A, yes, plus the slope below the load, yes, into I will do L minus A. Yes. So when I am doing below the load, I will take A. Now normal formula is what? You see, if this is L, M, so normal formula for deflection is ml square by this, and slope is ml by EI. So when I use here, I will use A. A is how much? A is L by 2. So here I will use A, right? In this 2 I will use what? A. So it will be M L by 2 square divided by 2 EI plus M L by 2 by EI, right? In place of L, I will use A, right? And then L minus A is this portion. This is how much? L by 2 only. So if you solve this, you will get 3 ml square by 8 EI. So this kind of questions are very hit in your GATE examination, where they don't mention the load at the free end, but somewhere. They can ask, yesterday also I told they can ask the same question. Okay. Now you do this for me, okay? Okay, you do this for me. If deflection at free end is equal to alpha PL cube by EI, find alpha. And find in fraction, don't find in decimal, find in fraction. Tell me, you solve this question for me. So here also what we can do the same thing. Here we'll apply the load till A, where A is here L by 2, right? And then deflection at free end will be deflection below the load plus slope below the load into L minus A. And here when I'm taking in place of L, I will use what? So easily you are able to find out, you see. So deflection below the load, I will use what? P A cube by 3 EI. So A cube means I'll use L by 2 cube by 3 EI, right? Plus slope will be PA square by 2 EI. So PA means I'll use L by 2. PA square by 2 EI. Then L minus A is the remaining portion. Remaining portion is L by 2. So if you simplify it, you will get how much? Pi by 48 PL cube by EI. So in the examination, now see, very easy. Now in the examination, they can ask any question. They can place L by 3, L by 4, L by 5. See, wherever they place this load, you can easily find out the expression. Yes, if you remember the standard formula. If you remember the standard formula, if they place anywhere, still you can find out the deflection at the free end. Right? Similarly, here also for the moment, they can place moment anywhere. If they place moment anywhere, still you can find out the deflection at the free end if you know the standard formula and this method. Okay. Now we will solve a question of spring using these concepts. Okay. We'll solve a question of spring and deflection. Okay. It's an interesting question, so therefore I have put here. This is an interesting question. Asked in GATE 2022. Now, how to solve questions of spring? Yes. अरे यार स्ट्रेंथ ऑफ मटेरियल सेम ही होता है भाई क्या यार ये तुम अगर गेट का तैयारी कर रहे हो, इफ यू आर प्रिपेयरिंग फॉर गेट, till now you don't know that it is almost same, so what can be told to you? As if you know the strength of material of mechanical is different from civil. Okay, it's like like put some common sense. If you are preparing till now, you don't know that how the see you have studied strength of material, right? You are seeing the questions and you don't know that these questions are helpful for you. You're not. Then you are not prepared, man. You are just in illusion of preparation. If somebody have studied and they are doing this previous year question and that person is unable to see that these questions are similar to the questions what I have solved in mechanical, then then you have not studied only, right? God bless you if you intend to get blessed. Okay, now see this kind of questions. You see how to solve this kind of questions when we have springs. Okay, when we have springs. Okay, now I will solve this question after I tell you some other concept. Now suppose I have a beam like this and I have a spring like this. And suppose I am applying a load here. Okay. Okay. Now how to solve this kind of questions, spring type of questions, and then we will come to the original question also. First we'll understand the concept. Now see here what you do, you separate the beam and spring. Okay, so what will be happening, you see, if you separate the beam and spring, so for the beam this P load will be acting here, this P load will be acting here. Now since this load is applied, the spring is getting compressed, so there will be generation of spring force in the spring, right? So what will happen, this spring will exert a reaction R on the beam, right? Yes, this spring will generate a R on this beam, right? Yes. See, Mr. Chris, I didn't tell you to solve. Okay, I told you to focus on this. So if you want to solve yourself, okay, and I didn't ask you to solve, okay, so what you do, you can open the previous year book and you can solve and be happy about that. Okay, so if you're attending the session, I told focus on this. If you don't want to focus, you want to show that you know you are a very knowledgeous person, that you know I can solve faster than others, then do this show up somewhere else. Don't do here. Okay, because I am here trying to explain this concept. And if you know the concept, if you can solve the concept, you are great, you are genius. Mr. Sell is also genius. So go somewhere and do this genius giri. Okay, don't do here. I didn't tell you to solve that question. Yes, I didn't tell you to solve the question, right? I told you to focus on this. And if you know the concept, then why you're attending? Because it is not to show the knowledge, okay? Go and show knowledge in the GATE exam. Don't do in my class. Okay, don't do. Come. Okay. So what I was telling, that if a P load is applied here, so I am trying to draw the free body diagram here. Okay. So what will happen? This beam will compress this spring. So spring will exert a reaction force R. Now since spring will exert a force on this beam, so an equal and opposite force will be exerted on the spring. Yes, so this will be the free body diagram, right? This will be the free body. Again I will tell. See, this load is applied, so beam will deflect like this. So when beam deflect like this, what will happen? It will exert a force R on the spring. So spring will also exert a force R on the beam. Or I can say that when this beam will deflect, so spring will exert a force R on the beam and equal and opposite force R will be exerted on the spring. So this will be free body diagram. Now another interesting concept, this is the free body diagram, another interesting concept. Suppose this is bending like this. Okay. Now after bending, it is looking something like this, right? So this is before bending, and after bending if I draw, it will be something like this. No, here I will draw here only. Okay. Yes. Now another important concept here is, you see, this amount if you see, this is what? This is the deflection in beam, right? This is the deflection of beam. Now this deflection of beam is equal to what? The compression of spring, na? Yes. The deflection of beam is equal to the compression in spring. So this is a very important concept which we use while solving question of deflection and springs. That this deflection of the beam is equal to the amount of compression in the spring. Now, if we see the spring only, yes, you see the spring only here. Spring, how much force is applied? R, right? So we know that spring force, this is the spring force, means how much force is acting on the spring. So we know that spring force is equal to the spring constant into the deflection or compression of the spring, right? So from here, the spring force which is R, so from here I can find out the compression of the spring, suppose delta amount, suppose this is delta. So this compression of spring becomes equal to what? R by K, where R is the force on the spring and K is what? The spring constant or stiffness also I can say. This is the spring constant. Now using these concepts, we can solve the questions of springs. Like these two questions we will solve now. Okay, two difficult questions we will solve now. Now see this question carefully. What is given? That many things are given. Okay, many things are given in this question. But what is given? That the spring, the force in the spring becomes 0. This is given here. Now this is some arrangement is there, and they're writing that the spring, the force is 0. So I will redraw this particular thing. There is one beam here, you see. There is one beam here. There is another beam here, right? There is another beam here, and there is a spring connected like this. There is a spring connected like this. Yes. And then there is a load acting here. Yes. There is a load acting here, and there is a load acting here. Yes. There is a load acting here P, and there is a load acting here Q. Right. Now they are telling that the force in this spring becomes 0. When the force in the spring will become 0? You tell me. When the force in the spring becomes 0. In a spring, if I am telling there is no force acting, that means what? Indirectly meaning is what? Tell me. When I say spring force 0, indirect meaning is what? Tell me. What is the indirect meaning of this? Spring force 0 means, what is the indirect meaning of this? Spring force 0 means, indirect means is, yes, there is no deformation of spring, neither compression, neither extension, right? No deformation of spring. No deformation of spring, right? There is no deformation of spring. Yes. Now, how is it possible that there will be no deformation in the spring? It is possible. How? You see, there is a P load acting here. If suppose this beam bends like this, and there is a Q load acting here, and this beam bends like this, suppose this deflection due to P, yes, this becomes equal to this deflection due to Q, then what will happen? You see, this spring is like this. If this deflection is slipping same, so the spring will be displaced to this position, right? Yes, you see, it will just get deflected, and there is no net deformation in the spring, right? Yes, yes. Spring force 0 means what? That means there is no deformation of spring, right? Yes. If there is no deformation of spring, that indirect meaning is what? Indirect meaning is that the amount by which this beam has deflected, the same amount this beam has deflected, right? Yes. Same amount of deflection has happened here, right? So now we know, so you see, now it is given, the length is given 2a, this is given EI. So this is 2a and it has a EI, and you see here the length is given A, and this is 2 EI. Yes, it is given 2 EI, and here this is A, this is A. Now this deflection will be how much? This is a point load acting at the free end for this beam. This will be load into length is how much? 2a cube by 3 into EI. So this becomes how much? 8 PA cube by 3 EI. Now how to find out the deflection at this free end due to this load? This will be Q. Now remember, we just found out this, right? If you see, we just found out this formula. Yes, remember that just we solved this question, that where it went. Yes, we just found out this. You see, when a load is acting at the midpoint and total length is L, then the deflection at free end is how much? 5 by 48 PL cube by EI, right? So we can use this formula, right? You can use this formula here. Yes. When you use this formula, see the formula we got what? The formula we got is 5 by 48 P, here Q is there, PL cube by EI. But here you see what changes we will make. Here length is not L, it is what? 2A, na? So this will change to what? This will change to, in place of A, I will put what? 2A cube, right? And then here it is not EI, it is 2EI. So this will become how much? 8, and this 8 will get cancelled. I'll get 5Q A cube by your 8, 6, 12 EI, right? Understood this? Understood this formula? Yes? The formula is this only, right? You see, when a point load Q is acting at midpoint with length is equal to L, then the formula we got what? 5 by 48 and then QL cube by EI, right? Now here this total length is 2A, so I put 2A, and this EI is 2EI, so I put 2EI, right? Yes. So this is 8, so it will become this. Now see what has happened. This deflection and this deflection is same, right? So now I can equate them, right? I can equate them. So 8 PA cube by 3 EI is equal to 5 QA cube by 12 EI. So you see this EI get cancelled. This is 12, this becomes 4, right? This A cube get cancelled, and Q becomes equal to what? 32 by 5 into P. What is happening? Q becomes equal to 32 into P by 5. So P is given how much, you see? P is in this equation is given, P is given 100 kilonewton. So all the rest data was not used. So 100 by 5, so this gives me 640 kilonewton. Yes. So very easy. Okay. Now see, they will not repeat this question in the examination, right? They will not repeat this question. They will repeat the concept. Yes, they repeat the concept. They might ask you in a different manner, right? Yes, they might ask you in a different manner. So we'll solve another question related to spring. Okay. This question, okay. We'll solve this question which was asked for springs. See here two beams are there, okay. You see here, I'll redraw this diagram for you. There are two springs here, okay. Two beams are there which are connected by a spring, like this, okay. And then there is a point load P acting here, yes. Then there is a point load P acting here, and then this has a stiffness K, and the value expression for K is given, okay. Now they're asking the percentage of, for the load P shown, the percentage of the applied load P carried by the spring. What is the meaning of this? That percentage of applied load carried by spring. Basically they are asking to find out what? The reaction force or the spring force in the spring. And this spring force you can find out in terms of P, na? Yes, this spring force you can find out in terms of P. So once you find out in terms of P, you can find out the percentage. Now, percentage of applied load carried by spring means what? Indirectly, they're asking you spring force R divided by P into 100. So this they are asking you, right? That percentage of applied load P carried by the spring. Yes. Now, first of all, you see here there is no information about that spring force is, obviously spring force is not 0 here, right? So now when you want to solve this type of question, first I have to draw the free body diagram, right? So what I will do, I will draw the two beams separately. So first this beam and this beam separately I can draw them, right? And spring also I will draw separately, okay? Spring is something like this, yes? See, now what will happen when you apply this P load on this top beam, then what will happen? P load is applied. So due to this P load, now this beam will exert some force on the spring, yes, and let that be R force, yes, reaction force R, and the spring will also exert, right? The spring will also exert an equal and opposite reaction force on this beam, right? Now, since the spring force has to be same in entire spring, so here also there will be spring force. What is happening, man? Double writing is coming. Again, I'll repeat, okay? See. Now, P load is there, right? So now, in the spring, there will be reaction R due to this load, and equal and opposite reaction will act on this beam. Now, since the spring force is constant everywhere, so there has to be what? Reaction force here. Now, since this beam is connected with this, so this spring will also exert an equal and opposite reaction. Understood? पेंसिल चेंज करने ब्रश के लिए तो, अरे ब्रश थोड़ी लिखूंगा, मैं ब्रश में नहीं लिखता हूँ ये ब्रश में लिखने के लिए बोल रहा है, इसमें मुझे लिखने में मज़ा नहीं आता है. आई विल राइट डाउन हियर ओनली. छोड़ो. हाँ, क्या बोल रहा था मैं? व्हाट आई वाज टेलिंग, सॉरी. हाँ, ओके. एवरीबडी अंडरस्टूड दिस फ्री बॉडी डायग्राम और नॉट? टेल मी. एवरीबडी अंडरस्टूड दिस फ्री बॉडी डायग्राम और नॉट? Everybody understood this free body diagram or not? Tell me. On the first beam, there is a P force, and then due to the spring, there is a R force. And in the spring, it is R only. So R and R. And since this beam is connected, so there will be a R force on this beam. Yes, now see, now interesting. Now this beam, both beams will deflect. Now I will deflect them. Now see, since the spring force is not 0 here, the spring force is not 0, that means what? This deflection and this deflection is not same, right? Yes, therefore there is some net deformation of the spring, and therefore spring force is coming into picture, right? That means this deflection, suppose delta 1, and this deflection delta 2, they are not same. They are not same, right? And suppose this is delta 1, this is delta 2. So can I say compression in spring? Can I say that compression in spring is equal to delta 1 minus delta 2 na? Yes or no? The compression in spring is delta 1 minus delta 2 na? See, it has, see, first you see, try to understand. It compressed by delta 1. Then this got deflected. So net compression happened how much? Delta 1, delta 2 na? See, again you see. First, the spring got compressed by delta 1. Then you see there is extension of delta 2, right? So net compression is how much? Delta 1 minus delta 2, right? Yes. So compression in spring is delta 1 minus delta 2. And compression in spring is always what? The spring force by the spring constant, right? This I have already explained, right? Compression in spring is always equal to what? The spring force by spring constant. Now delta 1 I can find out. What will be delta 1? See this free body diagram. Delta 1 means for this beam, right? Delta 1 for this beam, length is L and it is EI, right? So delta 1 for this beam, net force is how much? P minus R, P minus R downward. So I can say this will be delta 1 will be P minus R L cube by 3 EI. And for delta 2 will be, you see delta 2, only R force is there. So it will be minus RL cube by 3 EI. So this becomes equal to what? R by K. Now you can simplify this. If I open the bracket, you see this will become PL cube by 3 EI. Now see minus RL cube, minus 2 RL cube. If I take that side, it will be plus 2 RL cube. So it will be R by K plus 2 RL cube by your 3 EI. Now see K equation is given what? You see K equation is given 3 EI by 12 cube. 3 EI by 12 cube. So I can put here, you see, I can put here 3 EI by 2 L cube. Now you see, oh sorry, K is not there, sorry, only RL cube is there, sorry. Now see, this term is same, so I can make it 4 RL cube by 3 EI. Now see 3 EI get cancelled, L cube get cancelled, R becomes P by 2, that is equal to 0.25 P. So how much percentage? 25%, right? Yes. How much percent? 25%, right? So this becomes what? 25%. Everybody understood this question? Understood this question? Okay. Another question you will do for me, okay? Chalo, solve this question. Use the same concept. Yes. 5 by 16. That's very easy. You see, very easy. See, here if I draw the free body diagram, you see for the beam, there is P load acting here and there will be reaction due to spring, right? And then if I draw the spring, there is this reaction or spring force acting, right? Now here the concept will be what? Here the concept will be the deflection of the beam will be equal to what? The deflection of the beam will be equal to the compression in the spring, right? So here I can say deflection due to beam. So this deflection due to this load we have found out, right? It is 5 PL cube by 48 EI, right? At free end due to the load acting at center, right? We have found out this. So this becomes equal to the deformation or compression of spring. The compression of spring is what? Simply R by K. The compression of spring is what? Simply R by K. So deflection of beam is equal to compression of spring. So this is equal to R by K is given how much? 3 EI by L cube. 3 EI by L cube, right? So this get cancelled. I get a 16 here. L cube get cancelled. So R become equal to what? 5 by 16 LP. You see, so easily we are able to find out, right? So this kind of spring questions, if you know the concept, you can easily solve. Now solve this question also. Okay, so this is given, okay, and this is L by 2 and this is L by 2. Find the spring force in terms of W and K, W and L. Chalo, find out, very easy. Oh, we committed a mistake, man. Yeah, nobody highlighted this. Hey, we committed a mistake here. Deflection of the beam is what? Deflection of beam is not this. We committed a mistake. Nobody highlighted. Nobody highlighted this. We committed a mistake here. You see, the deflection of the beam will be combined effect of P and R, na? So due to P, it is 5 PL cube by 48 EI, right? Right? Now due to R, it is upward. So minus RL cube by your 3 EI. And this becomes equal to the compression in spring, right? So we forgot this R. We forgot this R, okay? So now this will be R by K, we will put 3 EI by L cube. Now what will happen, you see, when we bring this side, it will become what? 2 RL cube by 3 EI. Now this EI will get cancelled, okay? We forgot this R, committed mistake. So now EI get cancelled, this becomes 16. So now you see R is equal to 5P by 32. Okay. Understood? Okay. So here we forgot to take the effect of R, and load is not acting here, load was acting here. Okay. So when I'm finding the deflection of the beam, there will be downward deflection due to P and upward deflection due to R. So the deflection of B at the free end will be how much? This one, and this will be equal to the compression, right? Yes. Now use this concept and solve this question. So you see, standard formulas are very important, right? If you remember some 10 to 20, if you remember some 15 formulas, na, and some concepts how to solve questions like I'm doing now, you can solve almost all the questions of deflection of beams. So here I will just help you out. For the beam, if you see, there is UDL, and then there will be reaction due to the spring, and then there will be the spring here, right? Yes. So now you see, if we see here also the central deflection of beam is equal to the compression of spring, right? Now what will be the central deflection of the beam? It will be due to UDL, it will be 5 WL4 by 384 EI, right? If you see the central deflection, right? If you see the central deflection, it will be due to UDL, it will be how much? 5WL4 by 384. And then there is an upward reaction R, right? There is an upward reaction R. So due to R, it will be minus R L cube by 48 EI. Yes. And this will be, this is the central deflection, right? You see, it will deflect like this, na, central deflection of this beam, and that will be equal to the compression of spring, which is anyhow how much? R by K. So I can put here R by K. K is 24 EI by L cube, right? Your K is 24 EI by L cube, right? So when I put here, I can, if I do it 2 times, so this becomes 2, so it becomes 48. Then I'll take this side. This will become, you see, 5 WL4 by 384 EI is equal to, this is 48, 2 and 1, 3 RL cube by 48 EI. So again EI get cancelled. This will give me 8, I think, na, 8, 8, and this L cube, this becomes L. So R becomes equal to 5 by 24P. Sir, L by 2 hoga. What is L by 2? Why L by 2? No, if I draw it, what is your exact doubt? I didn't get. L by 2 half length पे P. No. स्प्रिंग के लिए क्या L by 2? Why it will be L by 2? What is your exact doubt? Let me draw for, see, for the beam, there is UDL acting and there is this reaction force acting, right? So the central deflection will be how much? 5 WL4 by 384 EI minus RL cube by 48 EI. Now for the spring, if I draw, for the spring there is reaction force R. Now for spring, how for the spring where there is L, the spring, how the spring knows that where the load is acting. For the spring it is just the R is acting here. How it depends, you know. For the spring only R is acting. See, suppose I put a spring here. For the spring it will always be this only, na. For the spring is always R. Okay, chodo. You are confused in your own world, so I can't help you out. Okay. The spring constant doesn't vary. I understood what you're telling. You are telling that for the spring I will use not L, I will use L by 2. In this you are telling, na. But this spring constant, it's a constant, na. How it will depend where the spring is placed. If I place the spring here, the spring constant will change. It will remain same only, na. बीम के लिए क्या बोल रहे हो? What you are telling, man? What is your doubt? What is your doubt? What is your doubt? You are telling that this point load is acting at the midspan. हाँ तो the point load acts at the midspan only, na. We use L or L by 2. हाँ हाँ, क्लियर क्लियर, नाउ क्लियर. थोड़ा कंफ्यूज नहीं हुए, बहुत कंफ्यूज हो गए. थोड़ा नहीं, बहुत हो गया. ज्यादा सोच लिया. You thought more than what is required. Now solve this question. Solve this question. Okay. The thought about the cantilever beam. Solve this question. Here also the same concept, na. Delta 1 minus delta 2, na. If this deflects by delta 2 and this deflects by delta 1, so delta 1 minus delta 2 is equal to the compression in spring, which is R by K, right? And then delta 1 will be how much? For the first beam, P will be acting, R will be acting. So it will be P minus R L cube by 48 EI. If I see the first beam will be something like this, right? For the first beam, P will be acting like this and R will be acting like this. So net force will be P minus R acting at the midspan. And then for second one, only R will be acting, na? So RL cube by 48 EI. And then this is R by K. So K is 3 EI by 2L cube, right? 3 EI by 2L cube. So now I can take this side. I need to make it 48 na. So I'll multiply 16 here. So I have to multiply 16 here, right? Then I simplify this. So this will become, you see, PL cube by 48 EI is equal to, this is 48, this is 2RL cube by 48. So 2RL cube by 48, that is 32. And this is 2, so 34 RL cube by 48 EI, na? I think so, right? So see, 48 EI, 48 R is equal to P by 34. So I think now if they ask you questions on spring, you can easily solve, right? Right? So I have solved many questions, not only from previous year, I added some more also from my side. Okay, very easy. Okay, understood. So this is the type of question they can ask you in spring. Okay. Okay. To solve last question, then that will be the end of this. Okay. And then in 7 PM session, I will come up with my questions. My questions are always better. See, I didn't solve very easy questions. Okay. From previous year, I tried to solve some unique questions which students find difficult. Now solve this question. Y is equal to this. I have asked the curvature. The curvature of beam. And what is curvature of beam? Curvature of beam is 1 by R, and we know from mathematics curvature is nothing but the double derivative of y with respect to x. So this question is very easy actually. Curvature is not R. R is radius of curvature. 1 by R is curvature. 1 by R is curvature. Very easy question. Two very easy question. One mark, very easy question. So double derivative of this will be, single derivative will be, this is actually mathematics. This is actually mathematics, na? Yes. This is actually mathematics. But they can ask, therefore they have already asked, so I just discussed this. What is the time? Okay. And this question I wanted to discuss. They asked last year. Very interesting question. I'll just explain to you. See, suppose we have a fixed column like this. We have a fixed column. We have a fixed column. Now, suppose I increase the temperature. If I increase the temperature, then what will happen? When we increase the temperature, there will be thermal stress, na, which will be compressive, na? Yes. When I increase the temperature, there will be thermal stress. There will be compression in this. This is a column. If I increase temperature, so it will try to expand, but since it is fixed at both ends, what will happen? It cannot expand. That means first, there has to be development of compression in the column, right? So now, what is the compressive stress? What is the compressive stress in column? And this will be compressive thermal stress in column, na? We know what is the equation of thermal stress. It is alpha delta T into E, right? Yes, this is the thermal stress equation. Thermal stress equation and both ends are fixed, right? Now when this thermal stress becomes equal to buckling stress, when this thermal stress becomes equal to buckling stress, which is, what was the equation for buckling stress? Pi square E by slenderness ratio square, right? And what is slenderness ratio? It is effective length by the minimum radius of gyration, right? Yes. So when this, try to understand, when this column is there, increasing temperature, so will try to expand, but since the ends are fixed, it cannot expand. So the supports will exert some force, and due to that, there has to be development of thermal stress. It is compressive. So when this thermal stress becomes equal to the buckling stress, then what will happen? This column will buckle. So if I want to find out at what increase in temperature it buckles, then what I will do? The thermal stress becomes equal to the buckling stress. So you see, thermal stress becomes equal to buckling stress. E get cancelled. So the increase in temperature required for this column to buckle will be what? Pi square by slenderness ratio square into alpha. And I can find out this increase in temperature. So this question was asked last year. You see, very easy question. Formula is very, concept is very easy. The differential increase in temperature at which the bar, or in this case we can say bar becomes the column, buckles. So you see, alpha is given. What I told, what is the temperature that I got? Pi square by your slenderness ratio into alpha. So alpha is given here. Now pi square we know. How to find out the slenderness ratio? What is given? The slenderness ratio, they have mentioned L by R is given. There's some, this question misprint. It should be L by R only. Only L by R is given. Okay, it is not slenderness ratio. It is only L by R. We'll remove this. Okay. L by R is given how much? 105. But L by R is not slenderness ratio, right? Because L is the bar length, right? What is slenderness ratio? Slenderness ratio is effective length by the minimum radius of gyration or radius of gyration in general, right? Now see what is given. The effective length of the steel bar is 0.5 L. It should be 0.5 L. Now why? Because when both ends are fixed, then what happens? Then it becomes a, both ends fixed means what? The effective length becomes equal to 0.5 L. They have given additional information. If they should not have given this to confuse some students, but they gave the additional information. Okay, theek hai. They gave to the students. Okay. So this will be how much? This will be 0.5 into L by R, right? Now L by R is given 105. So slenderness ratio will be 0.5 L by this. So this becomes equal to what? Your 52.5. Now we can solve this question, right? So this becomes equal to pi square. Slenderness ratio is 52.5. So 52.5 square, and alpha is given how much? 12 into 10 to the power minus 6. So how much you are getting this value? Very easy. You're getting 298. So you see, they can ask you questions like this. Okay. So this is the combination of concept of what? This is a combination of concept of, this is a combination of concept of your thermal stress and your buckling. See, you can also do it in this way also. That the, see, we can do in this way also. Okay, same formula will come out. Just I am explaining in a different way. That due to this increase in temperature, there will be reaction force developed. Suppose P. Suppose P. So reaction force is what? Reaction force will be, this is due to, due to thermal stress. This will be thermal stress into area, right? So thermal stress is what? Alpha delta T E and then multiplied by area, right? Yes. Now when this reaction force which is getting which we have got due to the thermal stress, when this becomes equal to the buckling load, then there will be buckling, right? Now from this I can write down thermal stress into area is equal to buckling load. So thermal stress will be equal to what? Buckling load by area, and buckling load by area is what? The buckling stress, which is pi square E by slenderness ratio square. Understood this question and concept? So they might repeat this question and concept. Okay. So almost all the difficult ones we have solved. Okay. So thank you. So more questions I will solve. Okay, comprising of all the difficult concepts and tricky ones. So that will be at 7 p.m. today only. So little break you can take now. So 7 p.m. to around 9:30 10 p.m. we will solve more questions, and those will not be previous year question. That okay, okay, that will be that. देखो वो इस्मात को लालची भेड़िया उसको देखो उसको उसको देखो उसको सी दैट. सो टॉर्सन वाला करवा दीजिए. ही इज टेलिंग दैट सॉल्व दिस क्वेश्चन. ही इज टेलिंग दैट सॉल्व दिस क्वेश्चन. बट वेट. I didn't solve this question. If I didn't solve this question, what does that mean? Am I fool that I didn't solve this question? Am I fool? I don't know how to solve this question. Why I didn't solve this question? Why I didn't solve this question? You know better than me that when to solve this question, when not to solve this question. Then why you are asking then? Why you are asking then? Tell me. Why you are asking? If it is easy, you know, then you solve yourself. Hey, if you know to solve this, why you are asking? Why you are asking? If you know how to solve it and be happy. Why you are telling that solve this question? Why? Why you are telling? Why? Tell me. What made you tell this? Your sorry won't help. I want to know your I want to know the psychic behind that. Means what is the thinking behind that? I just want to know what is the thinking. That when what compels you to tell that, okay, that नहीं इसको भी करवा दीजिए. Like what thought came to your mind, Hmm? What thought came to your mind to tell that, what curiosity, what curiosity. Okay, okay, okay. So I will continue the class. Okay, okay, okay. Continue the class. The teacher dies. Teacher is speaking from 2.5 hours. The teacher dies. His health goes down. He has already fever or not. That doesn't matter. It's like I will dictate the class. Okay, you are the master. I will serve you. Okay, let us solve this question. Okay, and I will solve more questions also. We'll continue the class till 7. And from 7 I will continue the class. I will continue till I fall down. Till I fall down I will teach. Okay. Pathetic. Okay. Chalo, solve this question. Chalo, solve this question. Let us waste some more time. No, let us solve this question, because he thinks that he will tell what to solve, what not to solve. Okay, I could have just solved that spring question, na. I could have just solved, not given the varieties. No, 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 you will solve, and otherwise no, 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 no. No, teacher doesn't know. Teacher doesn't know what. No, no, he will tell. Look, I will solve this question. Solve this question. Chalo, chalo, solve this question. And some more questions were there which I thought I will solve in that 7 p.m. session, but doesn't matter because doesn't matter. Doesn't matter. There is there is no consideration for the teacher. Okay, the teacher is just here to serve us. I will tell the teacher what to do. I am the Chalo, solve this question. Chalo, solve this question. I thought that I will take a break. I will have some refreshment, but doesn't matter. Doesn't matter. Because we are here to detect. Okay, if you don't solving, then I will solve. You see, there are two parts. One is shaft is this PQ part, one is OP part. You see, if I am seeing the torsion in this PQ part, it is how much? It is 1 kilonewton meter, right? It is 1 kilonewton meter. But if I am seeing the torsion in your OP part, it will be 1 and then 2 added. Yes? Okay. So, if this is 1 and this is 2 added, so total will be how much? 3 kilonewton meter, right? Because if I am seeing here, in this portion to balance, there has to be 1 kilonewton meter, right? Because here 1 is acting to balance 1. So in this portion, the torsion will be 1. But if I want to balance here, it has to be how much? 1 plus 2, 3, right? So next, if the maximum shear stress I want to find out in the portion PQ, then this will be 16T by pi d cube, because it's a solid shaft. So it will be 16 into T is your 1. So I will convert into Newton mm. So 1 10 to the power 6 divided by pi into D is 0.5 meter. So I'll convert into mm because it is asked in MPa. So 0.5 meter into 1000 mm. So I'll find out this value. Some mistake we have done. Oh, this is length. This is the diameter, 0.08 meter. Sorry. This is the length, sorry. So 0.08 meter means 80 mm. .95 MPa. Okay. Now if I want to find out the maximum shear stress in the portion OP, okay, it will be equal to same 16 into this is this, and by pi into the diameter in this portion is 0.1 meter means 100 mm. So 100 cube. So that is equal to, if I find out this, 16 into 3 to the power 6 divided by pi divided by 100 cube. So I'm getting 15.28. And and who was told na to solve this question for 7 p.m. class na, please send the PPT also. Okay, that which questions to solve, which questions not to solve. This is my email ID. Okay, you select 30 questions and send to me. Whatever questions you will tell, I will solve that in the class, because you know better na which questions to solve, which questions not to solve, right? So this is my email ID. I'll be waiting till 7 o'clock. The question sent by you, what is the name of that gentleman? I want to know the highlight the name of the what the gentleman name? Praveen, Mr. Praveen. Okay. So Mr. Praveen, you please send the questions which we will solve in the session of 7 p.m. So 7 p.m. class, we will solve questions provided by Praveen sir. Okay, so Praveen sir will send us questions, and the questions sent by Praveen sir we will solve, because Satyajit sir is an idiot. He don't know which question to solve, which questions not to solve. Okay, please tell na. Okay, whatever question you will send, we will solve, because you are the perfect person to decide that. Okay, I'm getting 15 point. Wait. Okay, he will send, he will tell what to solve, what not to solve, because I don't know what to solve, what not to solve. I don't know. Okay, now I will solve some other questions also, otherwise some people will come and tell that so Mr. Praveen is also will tell this also. So Mr. Praveen, please solve this question, please tell the answer, please, otherwise he will tell sir ye wala skip kar gaya. Please solve this question. Mr. Praveen will send the questions for 7 p.m. He will decide which questions to solve when. Solve this question. Other students, please solve this question. Please solve this question, other students. You have to find out the state of stress. Okay. See, this is mid-span. So at mid-span, what happens? Shear force is 0. If shear force is 0, shear stress has to be 0 in both P and Q. You see, there is only one option. You see, there is only one option where shear stress is 0 in both P and Q. And that is option B, right? Yes. There is only one option where shear stress is 0 both in P and Q, because P and Q both lie at mid-span, and shear force is 0, because when we have a UDL acting, the shear stress distribution, the shear force distribution is this. So SFD is this. So here shear force is 0. Now see, at P point is at neutral axis. So P point at neutral axis means what? P point neutral axis means bending stress will be 0. So normal stress also will be 0, right? P point is at neutral axis. So your normal stress also will be 0. And Q point is at bottom. Yes. So see, bending moment is not 0 at the mid-span. So bending moment is there. Bending moment is not 0. It's actually WL square by 8. But what happened is that P point is at neutral axis. So neutral axis, if you see the bending stress distribution, the bending stress distribution is something like this, right? Top to bottom. So here the bending stress is 0. And here it is compressive, here it is tensile. So at Q it will be tensile, therefore it is something like this. So this question we solved, okay? So some more questions I skipped. So I thought that I will solve this question in that 7 p.m. session, but Mr. Praveen will highlight this and tell that, sir, ye wala bhi karwa do. So we'll solve this question also. Okay? We'll solve this question also. It is a similar concept which I have told before. Yes. No. I will teach till I leave my body. Because Mr. Praveen has told that please solve that question. So then he will tell this question or that. So before he tells, I have to be, I don't want to give him chance. I don't want to give anyone chance to tell her a question. You know, they will tell that no, don't solve this question. If you solve this question in the next session, okay, if you solve this question in next session, then it will be a sin. And therefore, we'll solve this question now only. So let us solve this question. Okay. See, this is similar question which we have done before, right? Yes, which we have done before. You see. So what has happened is, you see, in this diagram, this is something like this. This is that plane, right? So this is that normal stress. This is the shear stress. Yes. And then you see, this is sigma y, na? And this is the tau xy. Yes. So instead of representing in this manner, you see, instead of representing in this manner, we have provided like this. You see, suppose this is that plane. Yes. So they have drawn like this, you see. And then they have drawn like this. Okay. So see, they have drawn like this. Understood this? How they represent in different manner the same question. So this stress is sigma y, na? And see, this is sigma y, na? And this stress is what? Tau xy, na? So indirectly sigma n is 5 and this shear stress is acting upward. So shear stress is -4. Yes. This sigma x and tau xy, they have asked maximum principal stress, right? They have asked maximum principal stress. So missing is what? Missing is sigma x, na? So to first find out sigma x from this. So sigma x is missing. Sigma y is given. Sigma y is given how much? 6 and the shear stress is positive. So 3 tau xy. 6 and this is 3. Now see, sigma n is given how much? It is given as 5. Now see, we can use shear stress also. Now angle is how much? You see, this is 45. So this also is 45. So with the vertical, this angle also will be 45. So theta is 45. Now this will be equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta. So cos 2 theta means cos 90 plus tau xy sin 90, right? So cos 90, these terms become 0. Sigma y is 6. So 5 is equal to, you see, sigma x plus 6 by 2 plus tau xy is 3, sin 90 is 1. So from here you see sigma x, how much I will get? I'll get 10 minus, this 2, 4. I'll get sigma x minus 2 MPa, right? I get minus 2 MPa, right? Yes. So you can also get sigma x by this equation. You see, tau is how much? Minus 4, na? Because it is given upwards. So tau is equal to minus 4. Yes. Tau is equal to minus 4. And that is equal to sigma x minus sigma y by 2 sin 90 minus tau xy cos 90. So again this term becomes 0. So from here sin 90 is 1. So this becomes minus 8. So sigma x becomes, you see, minus 8 plus sigma y, which is 6. So again I will get minus 2. So either you can use this equation or this equation. Now sigma x you got. Now they are asking measure principal stress. Measure principal stress is what? C plus R, right? So center will be what? Sigma x plus sigma y divided by 2. So sigma x is minus 2, sigma y is 6. So divided by 2. So 4 by 2 is 2. And radius will be how much? Root under sigma x minus sigma y by 2 whole square plus tau xy whole square is equal to sigma x minus sigma y. So minus 2 and then minus 6 by 2. So this is 4 actually 4 square, and this is tau xy is 3 square. So I get 5. So C plus R 2 plus 5, that is equal to 7 MPa. So this is similar to the questions which we have solved before, right? This is similar to the questions which we have solved before. And therefore I thought that I will skip, but then Mr. Praveen came in and he told that you cannot just keep the questions because I will decide what to solve, what not to solve. So we are following Mr. Praveen because I am the personal servant of Mr. Praveen. So whatever Praveen tells, we have to do that. Okay. So keeping in, एक बार साइन कन्वेंशन बता दीजिए. साइन कन्वेंशन बता दिया, ठीक है. नेक्स्ट. नहीं, वो साइन कन्वेंशन ही हैज टोल्ड. सो another master came. So another master came, my another master, so I have to follow him. Now I am the servant of all of them, so I have to follow. Even if I have told yesterday, but I will not follow, I will ask again and again. So we will study transformation of stress. So we'll study transformation of stress. Okay. So now in transformation of stress, we have a stress element. Now I have to tell all the sign convention. Otherwise, what will happen? Then Mr. Samuel will tell that please tell the other sign convention also. Then he will tell that please teach me the entire strength of material. Sir, please once tell me about the entire deformation of bars. Sir, please tell me entire shear force bending diagram. So let us wait some more time because we have got so much time. Okay, so this some more questions are there. So these questions we will discuss. Some more 2-3 questions are left which I intended to solve in this class, but I will solve in the 7 p.m. class because this is my class and I decide when to solve, when not to solve. And people who have problems that this is there, so they can file a case. So Mr. Ismat Praveen, you can file a case in the Supreme Court of the country that sir skipped 3 questions and instead of solving at 4 p.m. class, he solved in the 7 p.m. class. So it's a very serious mistake he has done. So I will please can file a case. Okay, other students who think that it is okay, so it's okay. Chalo, thank you very much. So see, the Supreme Court direct case nahi leta, ठीक है. So file in the district court or whatever court you have. Okay, that. Okay. Okay. What I was telling. So we solved many important questions. Yes. Now in the 7 p.m. class, if you attend, we'll solve more questions which will clear our concepts better. Thank you very much.